Good afternoon to everybody that's here. Welcome. On our agenda today, we have, actually first I'm going to talk about asking questions. So if you have any questions in this WebEx interface, you type your questions in the chat, and but all mics are muted. So, throughout the presentation, you can ask questions. We'll answer them as we can at the end of each talk. And our agenda today, we have two main items. So first of all, we're going to do, I'm going to go over a summary of our annual applications workshop and let you know where you can find the content for that. And I'm also going to go over our version 3 data reprocessing updates. And then I will turn it over to Zach Fasnacht, and he will be talking about the preliminary release of a really exciting nitrogen dioxide data product or data set that they're releasing. So moving straight into it, getting to the PACE Applications Workshop. In December, we had our 5th PACE Applications Workshop, and it was actually our first one to be in person, which was a pretty exciting adventure. We did this in Washington, D.C. On December 8th, which was the Sunday before AGU, the big AGU fall meeting, which was also held in D.C. this year. And, we had several kind of top level objectives with the workshop, such as we really wanted to inform our audience, of course, talk about post-launch status, data and related support tools, all those kinds of things. But we also really wanted to interact with people and take advantage of that in-person venue and, work on advancing user engagement, building community, and networking through different interactive sessions and time for focused on networking. And we also wanted to collect some actionable feedback, which we did through some interactive breakout sessions, which I'll talk about a little bit more in a second. And overall, it was a really fantastic workshop. We ended up having, we were excited to have over 110 attendees. They were from 20 states and 10 countries. This is a group picture here. We couldn't all quite fit in the atrium, so this is our group picture. I took it from the stage. And the thing that was really exciting about this is we succeeded in getting the broad audience that we were after. So there were some people that had never heard of PACE. Someone's asking if the slides are updating. Are you guys seeing the slides changing?
It's updating for me.
Okay. All right. Anyhow, we were really excited to have this succeed at getting a really broad audience. And what I mean by that is, so this on the right, there's like a survey we did at the beginning of the workshop saying, kind of what domain of interest do you have for PACE data? Where do you work, And we have people, of course, the oceans community was really well represented, but so was also terrestrial, aerosols, and clouds. So we were really glad to get, kind of across those, that spectrum that PACE works on. And we had a broad range of people from students to senior professionals. We had people with zero experience with remote sensing to experts in remote sensing data. And mostly as far as professions, we had people in the applied and research science and also data and computer science fields, but also there's some end user support, policymaking, and education folks as well. So it was a really great chance for all of us to come together, to share, to network, and to learn about how to get to work with PACE data. And as far as content, I'm going to do a high-level overview of the content for you. And the purpose of this is you'll know what we did, and you'll know what content you can go look at online. This is a QR code that will take you to our workshop archive. And so on the day of the workshop, we kicked it off with session 1, which was basically kind of setting the stage for the day. Jeremy Wardell, the PACE project scientist, started us off with a really great talk, giving a little bit of a history of PACE, as well as an overview of the observatory, which got the new people, kind of caught up that weren't familiar with PACE. And then he gave a fantastic talk after that on, the first 10 months of what we're seeing and where we're going. And then we had a great talk by Erin Urquhart from NASA headquarters. She talked about NASA Earth Action and how PACE applications is a part of that. And then we heard from Alicia Scott. She is our OBDAC Deputy Manager, and she gave us a great kind of very practical presentation on data access methods. So accessing data on the cloud, Earth data, also OBDAC. Go check out her presentation as well. And then after that, we went on to, if I can click my slides, session 2. Session 2 was really fun because it was lightning presentations. And the whole point was here was to hear from the non-PACE folks and really hear from a broad variety of people in the audience. Each person was given 2 minutes and 1 slide, and they basically presented on their work, why they're interested in PACE, what their application is, and how they think the PACE data is going to advance and impact that application for and benefit, end users on the other end. This was a really great way for people to also kind of introduce themselves to the group. And yeah, I encourage you to go watch those presentations. They were pretty great as well. And the other presentations that are online is for session 3. First, I gave an overview of the PACE applications program for people who hadn't heard of it before, and then went over some updates. And then we had 3 really fun talks. Each of these is giving us an idea of where applications are going with, we had an aquatic speaker, a terrestrial speaker, and an atmospheric speaker, each one presenting their work. Bing-Ching Liu talked about her work with phytoplankton community composition. Fred Heimrich talked about, he has fantastic work on using the hyperspectral land data from PACE to look at terrestrial phenology and diversity. And then we heard from Joanna Joyner, who is also, she's actually speaking about the same product that we are hearing about today. But today we're also going to hear about the actual data that's been released and hear a bit more. So those are all really great talks. I recommend all of them. And I should also note the slides for each of those talks are on the archive as well. So you have both the slides and a link to a YouTube recording. And then for the final session of the day, we had breakout groups. That one, of course, we don't have a recording of that. That was we had different tables. We had an aquatic table, a terrestrial table, and a atmospheric table of folks that had, questions as prompts and discussion ideas. And each group worked together to kind of provide feedback on, user needs, their experience, and each of these breakout groups provided a report. And so the results of those reports will go in an applications workshop report that's being developed. And then this question and answer panel, the last part of session 4, that is also online. That was where people had a chance to just kind of ask their final questions from a panel of people on the PACE team. So this was a really fantastic workshop. I want to thank the people that contributed, that attended. We definitely achieved our goals of, the audience that came, as well as, connecting everybody through networking and informing folks and learning a lot about what the community is doing with PACE data. So if you didn't come, if you weren't able to come, these are the ways that you can see what we did, how you can be involved. We have that workshop report ahead. It will be released on our website. Also, definitely go see that archive. All the parts that could be recorded were. And also, if you have some kind of data user feedback that you really want to contribute, that you maybe would have given in one of those breakout sessions, feel free to email that to us. We have a PACE applications address right there, email address. And, we're really interested, especially right now, in challenges and, to uptaking PACE data, like, is there some reason, things like that. So we welcome your feedback. And so what's ahead as far as events for the PACE applications program? The program always holds several events per year. We're going to continue, of course, holding these quarterly community teleconferences where the format is basically some kind of mission update in the beginning, followed by, a guest speaker that maybe is demonstrating a tool or has a new application, or maybe it's one of our new early adopters. And then we'll do that, every 3 months. And then we have our annual workshop. We'll have it again this year. It's going to be in the late in the year, and it will be virtual as well. We're going to be probably alternating each year, with in-person and virtual. So next year, or this year, sorry, will be virtual. We're also looking into doing some thematic focus sessions like we have in the past for things like water resources. or air quality. Stay updated. If you're not already, join our email list. You're probably on it if you're here, but that's where we're going to be releasing information on these events as the dates are solidified. And also, you can always feel free also to reach out by our email address for, one thing I'm interested in is if anyone out there has results on how PACE is advancing your specific application and that you would like to share. Always interested to hear those kinds of things and know what's going on with PACE data out there. Anyhow, that's what I have as far as, kind of, getting quickly through an overview of our workshop and where you can find the information to go watch online to catch up on any of those presentations you're interested in. And, so kind of moving from the PACE application scale, zooming out to the PACE mission scale, I'm going to transition the talk to discussing our PACE version 3 reprocessing, because that's really our big, and I'll take all the questions at the end after this one. That's really our big mission update right now. That's really the big happening is rolling out our level 3 version or our version 3 processing. As many of you probably already know, our first version was released in April. Our second version was released in July, and we are now rolling out version 3. It is in progress. As for a couple of specifics in terms of timing, the specs 1 products through level 1B and level 1C are completed, reprocessed. OCI products, the level 1B through level 3, they're expected to be added to the forward stream next week. And then reprocessing of the previous data before that will follow according to different disciplines and take a few weeks to march through all of those data files. Then the HARP2 reprocessing through level 1C is likely to be done by or happen in late February. And as for what specifically has changed, this is a kind of a quick kind of an overview of some of the major changes you all might be interested in when we're talking about moving from version 3 reprocessing to version 2 to version 3. So the OCI instrument has undergone several calibration efforts. You can read the details there if you're interested in how OCI was calibrated. I know a lot of folks are interested here in the ocean color products. So what's different there? So there's been refinement of the different, gas and BRDF corrections, but some of the exciting news is that there is going to be an expanded product suite. We're going to have phytoplankton fluorescence as well as phytoplankton community composition. Woohoo! So, from the Moana algorithm. And all the ocean color products are also going to be elevated to provisional status, which what that means is they can be moved to Earth data, basically. The data have matured enough, have had enough to be moved to Earth data. So provisional means on Earth data. That for the rest of these slides. So all the ocean color products will be moved to provisional status, found on Earth data. And then what about OCI land products? Also had some refined corrections as well as vicarious calibration to improve the data. And then there's also been an expanded spectral sampling for the surface reflectance product. It now has 221 bands. And there's also a new product being added to the land suite as well. It's land VI. And this land VI index is, as well as the surface reflectance products, they are all also going to provisional status and will be available on Earth data. So we can now get the land data on Earth data as well. For the OCI cloud products, these have been expanded at the level 3 level, doing things such as, separation of all the optical properties into the different ice and water paths and other efforts listed there. But all of the cloud products are also going to be elevated to provisional status and available on Earth data. And as for the OCI aerosol product updates, the new suite of products that comes from the unified aerosol algorithm, that's Lorraine Reimer's group, those products are planned to be added to version 3 or a part of version 3, but they're going a bit through a different kind of a review process as a new suite of products. And so the initial release of level 2 is expected in early March. pending how the reviews go. For both Specs 1 and HARP 2, updates there. Both of these got updated instrument calibration, reducing bias. And then as far as product updates, for Specs 1, the first NASA release of the level 2 and 3 Specs 1 aerosol products is expected soon. These are the ones using the Remotap algorithm. And if you are really excited to get your hands on these data before NASA releases them, you can also get them from the PEI's institution at the link we're providing here. And it's also in the chat. And then for HARP 2, there's going to be the first release of the level 2 and 3 aerosol products using the fast maple algorithm, and also the cloud products listed there. And these are all expected to be available in late February. So as for the OCI folks, for the ocean color folks, if you'd like to see some plots of how your data are changing, this right here is just a quick overview of the matchup statistics of OCI remote sensing reflectance compared to aerosol OC, to AeroNet OC's measurements on the ground. Those are the ground stations. And, we have the statistics such as the mean square error or mean absolute error versus the wavelength for version 2 in red and version 3 in blue. And the big takeaway from this is that the version 3 reprocessing is reducing, the error in both the blue as well as the red regions of the spectral range, which is fantastic. In short, your data are better. The system vicarious calibration is, among other changes, are making the data better with every reprocessing. So I will end this update with one reminder. You guys, if you've been to our talks, you've probably seen this already before, but I want to emphasize, if you want to go get all this great data that's coming, please make sure that you bookmark this page. This is a really important, this data access page. We keep this page live. It's really a one-stop shop for staying up to date on things like the current reprocessing version number, where are the release notes, what are the data access points, because there's more than one, as well as resources for working with the data. I really suggest that as a data user, you click through, kind of read this page from top to bottom and click through the different links. There's a lot of really useful stuff there that'll help you get started. So from there, I will take any questions. So moving on to Zach. So Zach is a research scientist at NASA Goddard, and he's supporting trace gas retrievals from UV vis instruments such as OMI and TROPE-OMI. He was a member of the PACE Science and Applications Team #2, where he used machine learning to develop gap-filling products for PACE OCI. His more recent research explores how we can use AI and machine learning to develop new capabilities for our existing satellites. And today he's going to present on a preliminary data set that they are releasing, and he's going to tell us, why it's unique and exciting, how they did it, and where you can go get your hands on the data.
All right. Thanks, Morgan. So yeah, for those who were at the applications workshop in December, I apologize. Some of this is going to be a repeat. I'm going to go through an overview of our PACE 2 product, some of the applications, then I'll talk about our initial data release, and I do have a quick example of how you can use our data. So, if you're seeing this again, I apologize that you'll have to enjoy it for a second time. So the motivation here, for those who aren't familiar, NO2 is a pollutant that's emitted both naturally and from anthropogenic sources, from wildfire, soil, lightning, but also from burning of fossil fuels, from vehicular emissions, and other anthropogenic sources. And it contributes to the formation primarily of ozone, but also of aerosols. And so it's really important to be monitoring NO2, and we've been monitoring NO2 from space for several decades now, from atmospheric instruments, including GOM, OMI, and TROPE-OMI, but at a much coarser resolution than we have available from PACE OCI. And so the question we pose to ourselves is, can we retrieve NO2 from PACE OCI? And I'll explain in a second why why that has to be posed as a question. Of course, the ocean color community here is very familiar with NO2 from an atmospheric correction perspective, because it's very important for atmospheric corrections, but it's also important for land applications, or applications over land as well, not just for the atmospheric correction solely. And so, like I said, historically we've used instruments like OMI and tropomi, they're atmospheric instruments, to do NO2 and trace gas retrievals. They have a really high spectral resolution compared to the traditional ocean color instruments. They have a spectral resolution of about a half a nanometer. PACE spectral resolution is about 5 nanometers. They have a much coarser spatial resolution, though. That's the flip side, is that the atmospheric instruments have a higher spectral resolution, but they're a lot coarser spatially. And so now that we're kind of bringing the two together, and the ocean color instruments are getting higher spectral resolution, but still retaining the higher spatial resolution, the question is, can we start getting some of these trace gas measurements from the ocean color instruments as well, with their spectral resolution? And so this is a plot showing the NO2 absorption cross section as a function of wavelength. And so in blue is the spectral resolution of about half a nanometer, which is the spectral resolution that we get from our atmospheric instruments, being OMI, tropomi, tempo, and some other instruments. And so you can see that these very high frequency features are the NO2 features that we typically retrieve in our traditional NO2 algorithms. And you see in the red there is if we smooth to the PACE spectral resolution. So you can see that while you still see some features, we smooth out a lot of the high frequency information in the spectra. And so, the question we have to pose to ourselves is, now that we're removing a lot of the high frequency information, can we still retrieve NO2 at the coarser PACE spectral resolution? And so we apply a machine learning technique to determine whether or not we can get NO2 from PACE. And so, hopefully this isn't getting too technical, but the approach here is that we take the measured reflectances from PACE and decompose them into principal components. The principal components essentially take those measured reflectances and separate out a bunch of different features within a spectra into independent principal components. And then we take those principal components, we provide them as an input to a machine learning model that's going to learn how to estimate the NO2 based on those principal components. It essentially is learning the relationships between our measurements and a retrieved quantity. Since PACE doesn't actually have trace gas retrievals, we co-locate them from an actual atmospheric instrument, being tropomi, so that we can have a training data set to train the PACE data to estimate NO2. We actually use the 5 kilometer reflectances from PACE to develop our model, because that's closer in spatial resolution to tropomi. And then once we develop that model, we actually just apply that model to the higher resolution 1 kilometer PACE data to get high resolution NO2 retrievals. And so this is an initial result. If you were at the applications meeting in December, you've already seen this result. This is NO2 total vertical column density of NO2 over the LA basin from April 28th to April 30th of 2024. And you can see that because we have the higher spatial resolution from OCI of about 1 kilometer, that we see a lot more of these features of NO2. We can start picking apart individual highways. We can start looking at some of these smaller suburbs and actually start looking a lot better at, or a lot closer at the sub-city emissions of NO2 with this higher spatial resolution from PACE. You can see tropomi and tempo here, which are the atmospheric instruments that we use for trace gas retrievals. And while they show similar patterns, they don't have the spatial resolution to be able to, understand some of these finer scale details. So this was shown in December. We can then take these measurements and do a multi-day average to downscale and get even higher resolution information. So this is a new result. It took 3 days at the end of September, and sorry, that should just say September 26th, 28th, not Thursday. But it took 3 days at the end of September and downscaled the NO2 from these 3 days over LA. And so I downscaled it about 500 meters from PACE and about 3 kilometers from tropomi. And again, what you can see that they generally compare really well. You can see a lot more of these finer scale features out of PACE, and so you can really start picking up apart these individual highways in LA. You can start looking at some of these smaller suburbs down here in like Anaheim, down towards Riverside. Um, and interestingly too, the reason I put this Google Maps image here, you can see, there's a lot of small mountains and higher terrain in Los Angeles, and so the NO2 tends to get stuck up on side of the mountains. It doesn't rise up to the mountains. And so with this higher resolution from PACE, we can actually see, where we have this higher terrain, that we do have the lower NO2. Excuse me. And up here to the north, you see this little area with lower NO2, and again, you see some higher elevation. So because we have this better, finer spatial resolution, we're able to see a lot of better, or a lot more of these finer scale features now from PACE OCI than we'd be able to from our traditional atmospheric instruments. Here's an example in Riyadh, Saudi Arabia. There's several power plants in Riyadh, and they're labeled by P, and then there's some cement factories as well that are labeled by a C. And so when we look at the NO2 from tropomi, it looks like one big area of elevated NO2. But when we get over here to OCI and start looking at the NO2 that we can get from the machine learning approach using OCI, we can start separating out some of these individual sources of NO2 and actually see, where that NO2 is coming from. And if we come down here to June 17th, you can, piece apart each one of these power plants, and you can kind of even piece apart the emissions from this cement plant down here to the southwest. And you just can't really pull all that, tease all that information apart. These two power plants kind of look like one big plume right here in the central part of Riyadh. And here you can see from PACE OCI, because we have the higher spatial resolution, that we can start teasing apart these different emission sources and their plumes as they're blown downwind. Here's an example back in the States in the Ohio River Valley. There's numerous coal-fired power plants along the Ohio River Valley. And so again, the power plants here are labeled in P. And so from tropomi, here's two different power plants, and you can kind of see basically one plume. But from PACE OCI, we can see that we can separate out these individual plumes and get a better understanding of the emissions from each one of these plumes. Here on June 12th, you see a similar thing that this is the city of Louisville. There's a power plant to the south, and from tropomi, it just kind of looks like one area of NO2. But if we look at the higher resolution PACE OCI data, you can tease apart the actual emissions from the city versus the emissions that are coming from this power plant. So again, the OCI data is really helping to tease apart different emission sources. This is NO2 in Detroit, and this one I find to be cool. If you look at this figure down here in the bottom, you have the downtown Detroit here, northern Detroit here, and then there's also a Ford plant in Dearborn, Michigan. And if you look really closely, there's a little maxima right here, and that's exactly where that Ford plant is. And so because we have the higher spatial resolution information from PACE now, we can actually start pulling out features like this little Ford plant in Dearborn, Michigan, that you just can't actually separate with the coarser spatial resolution from tropomi type instrument. Another example in Saudi Arabia, again, several power plants. There's a desalination plant right here along the coast, a few steel factories. And again, you can see here, there's several different sources up here in the northern part of the map, and we can start pulling apart the individual plumes and tease apart these different emission sources and really get a better idea of the actual emission sources from each one of these plumes. Whereas from the atmospheric instruments, we certainly see a plume, but we're not able to tease apart the NO2 emissions from each one of these sources with the coarser spatial resolution. Here's an example of downtown Seoul. And again, you can see that we're able to see much better spatial resolution. There's to the north of Seoul, there's actually some mountains right in here. And so we're able to see the lower NO2 where those mountains are and how it's kind of capped. It's high along the mountains, but over the mountains, of course, there's none. And then there's this little region kind of in the middle of the mountains that has some elevated NO2. You can also see some elevated NO2 right here from this highway, which must be one of the more the busier thoroughfares coming in and out of Seoul. And you just can't really tease apart that information from the coarser tropomi. You can start seeing some of these suburbs and some of these smaller cities on the outskirts. So again, with the higher spatial information from PACE OCI, we're just getting a lot finer detail information. Here's another power plant in the United States. This is in Montana. It's the Colstrip power plant, and we can see the plume from tropomi on both of these days, but you really can see the finer detail of this plume from OCI. And if you look at these two plots from tropomi, you can't really tell exactly where the source of the NO2 is. It's somewhere in here, but from the PACE OCI high spatial resolution, we can tell exactly the source is right there. And on the 25th of September, with tropomi, it kind of looks like the plume is going a little bit north-northwest, but it will get this PACE OCI at higher spatial resolution. You can see that it appears that the north-northwest was more just a result of the orbital track, and that the plume is actually just going more to the north. And you can even see that due to some vertical velocity and some mixing, there must be a little bit of a break in the plume. It must be going up and down a little bit. So again, you have just great information about out of this higher spatial resolution from PACE. Unfortunately, wildfires have been in the news a lot lately, and so I decided to put together an example of some wildfires from Oregon this past July. I believe 2024 was the worst wildfire season for Oregon in history. They had over 1 million acres burned over the year. And so here's some fires that occurred in eastern Oregon in July. And you can see the hot spots for MODIS up here. You can see the tropomi NO2 retrieval, and you can see the elevated NO2 from these wildfires. But with PACE OCI high spatial resolution, we can actually start teasing apart each one of these individual hotspots or each one of these individual wildfires and see the NO2 emissions from each of the fires. And there's another fire down here to the south, and with PACE OCI, we can really see the detail of this plume that matches well with the imagery from MODIS Aqua. And so before I get into our data release, I just have one more quick example. This is Southeast Texas, and you can see in tropomi both San Antonio and Houston, but you don't really see too much in these other areas. You can kind of see Austin a little bit there, but with PACE, we're actually able to start seeing some of the NO2 from these smaller cities. Austin right here, College Station here, which is Texas A&M University, and then up here is Killeen, Texas. So again, with the higher spatial information from PACE, we're able to start looking at some of these smaller NO2 sources that you just can't see with the tropomi NO2 retrievals. And so, like Morgan had mentioned, we have released some of these data because we want people to start looking at them and letting us know what they think, and telling us if they find anything, any issues, or find any good applications for these data. So we processed about 3 months of test data for folks to explore. It covers North America and the Middle East region from April to June of 2024. They've been temporarily released through the NASA Aura Validation Data Center, which I'll show you in just a second. And when I produced these, I developed them in an SCDF format. I tried to make them similar in format to the PACE file format. They're level 3 gridded files at 1.5 kilometer to make it easier to use. They included the total vertical column NO2 in these files, zonal winds, and then the latitude and the longitude. So it's a pretty bare bones file right now. If anybody wants anything else in them, feel free to let me know, and we can produce additional data as well upon request. Eventually the plan is to, of course, produce global data for folks to start exploring, but I wanted to at least get some initial data out there so that people can start looking at this NO2 data and exploring what potential applications are for the data. One thing that I didn't highlight that I guess I'll mention now is right now we're just developing these retrievals over land. This approach doesn't seem to work as well over water at the moment, which is of course unfortunate for ocean applications and for atmospheric corrections. I think that there's some difficulties in the weaker signal over water, and so I think the NO2 it's just not as strong a signal over the dark waters, but we're certainly trying to see what we can do over the water to see if we can improve things and get some NO2 retrievals over water. like I said, we have released the data through the NASA Aura Validation Data Center. That's just somewhere that we release some of our research products so that people can take a look at. And they're very easy to download. There's no user login or anything like that that's needed. You can just go to the website and download them. You can use a very simple wget and you'll just go ahead and download them. And so I'll show you real quick. This is the Aura Validation Data Center, and so we'll just take you here, and you can choose, if you want North America or you want Middle East. It'll just give you a list of all the different files that we have available. You can just click and download. You can use the wget command. You can use the curl command. And so I put together a really quick Google Colab just to show how you can use these data. For those who haven't used Google Colab before, it's a really nice tool. You can basically run a Python notebook in Google Colab and have access to your data in your Google Drive. So it's a nice little tool to just do quick little test demos. So I'm using Python for this little demo. Just gonna import the libraries that I need real quick for this to run. And then I just have to mount my Google Drive and say yes, and then gave it permission earlier. I was hoping that it would accept permission from earlier, but I guess it needs permission again. So once that's mounted here, I already dropped a sample file in my Google Drive so that I'm able to access that. And then, like I said, there's not too much in these files, just reading in lat long and then the NO2 vertical column. And I try to base the terminology similar to how the terminology is in the PACE data. So I'm just reading in the NO2 data, making a map and making a custom color bar that's works well for NO2. And then since these data are gridded, I can just use a simple imshow command to plot these data. And if I do that in 1 second here, it will pop out a map of NO2 for May of 2024. And so here we have a map of our NO2 product for May 1st of 2024. You'll see that at the moment, we don't include any data under cloud, so that's why you don't have why you have all these gaps. And like I said, we are focusing only on land at the moment. But you can see all these sources. Now we can then take that and zoom in to get a better picture since this is pretty far zoomed out and pretty small. And so here we zoom into the Southwest United States, we can start seeing Los Angeles and San Francisco and some of these other cities out here in the Southwest United States. So, hopefully people will start using this data set. I think there's a lot of interesting applications from this data set that we could that could potentially be explored. So, it's out there. Start using it, and feel free to let us know if you have any questions. So I'll stop there and open it for questions.